Hi John, Paddy and Lucas here. Going to talk about our game. First of all, going to talk about the gameplay. It hasn't changed since the last SEA. You've still got your farmer who can shoot, and you've got your UFO who can beam. Just as a warning, when I'm talking about the sound in it, like the gunshot, it's going to be very loud, so you might want to turn your volume down when I mention it. So, like now, one of the parts of the game is you can shoot your gun, uh, and then the client can, the UFO has its beam, can pick up cows, and the aim of the game is to UFO to pick up all the cows in the game, and the farmer to kill all the UFOs. Uh, so uh, about the server, there's some of the objects rendered on the server here, and as you can see, we've got a debug on, so we can see our collisions. These can be turned off, but we just have them for handiness sake. As you can, it renders all the objects that are passed through to the server. So the UFO, which is here, the cows, the farmer, and again I'm going to shoot. You'll see bullets. Sorry, yeah, you'll see them there. But on the client, the backgrounds are rendered. The reason we didn't pass them through is because there was no need. The objects are never updated, so your trees and your clouds didn't need to be rendered on the server. There's no prediction in the game. We had to strip out the prediction from the RoboCat client, which is heavily layered upon. We took it out because it didn't work on our objects, and then as it came later on, we couldn't figure out how to get it back together. So majority of the code is the RoboCat code. Lucas has done a lot of work on it actually, which he will talk about later. But one of the things just going to mention is that it's one of the main things is it's adapted the code to SFML. So here in the engine you can see the render window is changed to an SF render window from the SDL SDL. So the collision detection, it's the similar to before. So the collisions that were in the game. So when a player shoots, I'm going to shoot again. Sorry with the volume. If it hits the UFO, the UFO's health goes down. What happens now is that the collision is rendered on the server instead. So it does all the calculations on the server instead of on the client, so that there's consistency. Next, I'm just going to talk about my sound, which is what I worked on, and then I'm going to pass you over to Lucas. Oh yeah, before I talk about sound, one thing I want to point out is that Lucas did actually do a significant amount of work, and you're going to see this yourself throughout it. I really struggled with the code. I helped out on a few things. You'll see throughout our code we're going to put in comments after we do the screencast, and basically it's going to say like Paddy worked on this, and then to be honest, otherwise it's just assume Lucas did, because again, like a lot of the stuff I did work on was broken and Lucas helped me fix. So, but the sound is basically one thing I did myself with a few comments from Lucas every now and then to help me out. So I created this sound holder, so I could store all the sounds that were going to be played in the game, but we ended up only with one, the gunshot. So first of all, what it has is it's got two maps, and one of them is a sound buffer, and one of them is an SF sound buffer map, and then the other one is a SF sound map. And for the sounds to work in the game, you have to have a buffer, and you have to load your sound into it, and then your sound needs to have a buffer, and then you can play it. So it's much like a texture and a sprite. So I loaded in the gunshot WAV file, and loaded it into the buffer, inserted the buffer into this map, and then set the buffer to a sound, and then put it into its map. And then for the play, it just finds it using IDs. So it's got like a sound IDs enum header, and then just play it. We actually had like quite a bit of problem with this because the sounds the sound creates a thread, and when it goes out of scope, it like the sound won't play, and like that happens in a fraction of a millisecond. So we were like wondering like why none of the sounds were playing. It was actually working. They were just going out of scope. So this is like an example of where it's called. So where the bullet is replicated in the is created in the replication manager client, it just plays an instance of the sound gun, sound ID gun. That's all I'm going to talk about, and I'm going to pass you off to Lucas now.
Thank you, Paddy. And now I'm going to talk more about the networking behind our game. So I'm going to start with the protocol that we are using. So we are using reliable UDP protocol. And I'm going to also talk about initial connection and what is happening. So as you can see here, we have 4 different types of packets. And then I created enum for them because I also optimized all of the packets that are being sent. That is only, all of them are only 2 bits. And there is the hello packet, welcome packet. So client sends the hello packet to the server, and then he receives the welcome packet, which is with his client ID and the name. And then client is sending the input packets, and server then receives the input packets, process them. All of the processing is done on a server, and then a server will send the state of the game packets back to the client. So I'm going to start with packets that are sent from the server, and I have a breakdown done in this Word document. So as you can see that all of the packets that are sent from a server are basically state packets, and I'm going to talk about main packets, which are UFO. All of the packets that are sending is the objects, which are UFO beam, which is cow. Then we have the farmer object. Then we have the gun object, bullet object, and a cow counter object. So in UFO, I have a breakdown here. We are sending, and also I will include this document with our submission so you can read through it, but I'm gonna go through it. So as you can see, we have a partial object replication which came with the RoboCat, but we also use it. And I pack all of the important stuff. So as you can see, we have player ID, and I know that there won't be more than 255 max players for our game. And that's why I have it packed to 8 bits. Then I have a position for UFO, which are we sending, and is its maximum positive number on our map is 495. It's going to be only 12 bits. Then we have a health, which is only 30, so I can pack this into 5 bits. Then we have a rotation, and this is packed to a maximum of 360, which is 9 bits. As you can see, I have 4 control bits, which is 4 booleans, and then I have 4 different numbers, and altogether is 38 bits for a UFO, which is 5 bytes, and I have 2 bits free, so if I'm packing it, I can use these 2 bits for something else. Keep in mind that this is not always 38 bits, because if UFO is not moving or something, the control bits are only sent. Then for UFO beam is only if a position changed, 1 control bit, and then 12 bits for the position. For the cow, same, 1 control bit and 12 bits for the position. Now for the farmer, I have again 3 control bits, position 12 bits, and I have a sprite change. So there is 5 different poses in a in a farmer, which can be packed into 3 bits. And as you can see, I also included how much bits I'm saving. So if it's all packed, you actually save 1 or 2 bytes maybe if you're lucky. For the gun, again, I have a position and rotation, which is 12 and 9 bits. Then for the bullet, I have a position and rotation, which is again 12 and 9 bits. For the cow counter, I have a maximum 17 cows, which I packed into 5 bits. Now I did a rough estimation, like for 20 players, if there is 10 farmers, each farmer has 10 bullets, then one gun, one farmer object. It'll be about 130 objects. If you have 10 UFOs, 10 beams, that's about 20 objects and about 17 cows. I know that there won't be probably more than 255 objects, so I also pack the object IDs to 255, and I'm reusing these IDs as I'm keeping the track of them. Now, for a server average packet breakdown, so this is the full packet breakdown. We write the type of the packet, which is 32 bits. Now I optimize this to 2 bits. So I have only 4 types of packets, which can be from 0 to 3, so I need only 2 bits, so it's a nice saving right there. Then I have a sequence number, which is 2 bytes. I have a boolean, which if it has pending X, then if that is true, I have a sequence number, which is another 2 bytes. I have a has count of X, which is 1 bit. If that is true, I'm going to put the count of the X, which is uint8, which is another 8 bits. Then I have a timestamp. If that is 30, that's another control bit. I have then float, which is 32 bits. I have a network ID, which was before 32 bits, but I optimized it to 8 bits. This right in here was the massive saving when I went from 3000 bytes per second to 1000 bytes per second. So because I'm sending, let's say, 20 to 30 objects, and from each of these objects, which has network ID was 32 bits, I went down to 8 bits. Then I have a replication action, which is only 2 bits, which is optimized already. And then I have depending on the object and the dirty state of object, I will repeat step 9 and 10. So send ID and then action and then send of the state object. If I have, let's say, number of object which would be 20, then I have about 387 387 of bits, which would be 387 bits, yeah, with 20 objects. So it would be 49 bytes as to send one state packet. And then I will talk about estimation. And as you can see, I did a snippet right here. So this is when I'm sending input packet. So now I'm gonna talk a little bit about client and what client is sending. So with client, we're only sending 5 inputs, which is WSAD and see if the gun is firing, which is on UFO, which is beam, and on a farmer is gun. So again, I'm gonna write type of the packet, what type it is, optimize to 2 bits, sequence number, again has pending X, boolean 1 bit. If that is true, that's another 16 bits, 2 bytes, another boolean, which is if it has X, which is 1 bit, then if it has another 8 bits. Move count, now you can send up to 4 moves, so it's 0, 1, 2, 3, which is 2 bits. Repeat as many times for max, sorry, this would be 0 to 4, so it would be 4 moves. And then we have a input state, which is 5 booleans, that is packed to 5 bits. And then timestamp dirty is a float, which is 4 bytes, which is about 11 bytes in a packet. But as you can see, this will be most of the time 10, and then it can go up to 14 if you have more inputs in the packet. So, and also for server, as you can see, I have this printout, which is a stat packet for one UFO in the game with a beam, which is really small. As you can see, it goes from 38 bytes to 42. So it varies when I was pressing the beam. Next, I'm going to talk about if there is any more potential for compression. So there is one small potential for compression, and that is right here. So if I go into the client, and as you can see, this registry creation function that are also if I go to UFO right here, and I go to UFO, and all of these functions, as you can see, class identification, and they have a class ID, which is uint32t. And as you can see in here, in my client, I only have 1, 2, 3, 4, 5, 6, 7. For now, I have 7 objects. If I would plan to add more objects into my game, I would need more bits. But with 7 objects, I can pack this into 3 bits. total. So I could pack this, but as it was already coded with uint32t, I just left it there. But there is a potential for the compression. So from creation to destroy, what all messages are they sent? So as you can see, when you create object, when you fire, let's say, and you want to create a bullet, then you will need to, your network manager, give me a second right here. If I go to farmer on a server, and I'm going to update, and I'm going to gun server shoot. Okay, so that's right here now. So I want to shoot a bullet. So I will create a game object which was registered and add it to the object manager on a server. And as you can see, this is the creation function that was registered. Next, I will need to set all of the stats on this bullet, and then I will need to call which of these were changed. As you can see, set state dirty, and this will only replicate whichever state was dirty. As you can see here, it's only replicating the rotation as you rotate the as the bullet rotates. So it only partially replicates what it needs. And then when the bullet is dying, you will handle dying, which is you will unregister this game object, and that will propagate towards the, it will call the replicate destroy action, and then it'll propagate down to the server. So you can see that you have the replication manager right here, and you have the three actions, which is write create, write update, and the write destroy action. And if there is a new object, it'll write create action. If there is an object that needs to be updated, it'll write update, and then if it needs to be destroyed, it'll write destroy. And as you can see on the client, that's one more thing I can show you right here. Where is it? Red. So if I go to a client and I'm going to check my process incoming packets, because that's what I'm getting. I'm going to check my packet queue, and is right here, handle packet. I'm going to read packet, and as you can see, it reads the action right here. Everything is optimized. You can see that I'm reading 8 bits, 2 bits, and in the class we had the error with the remaining bit count. I couldn't replicate the error at home as I don't have enough machines to test on, so it's probably still there, but rest is optimized. And for whatever action it was, as you can see, here is the create action. Then it goes and create, and as Paddy was saying, there with the create action, it checks for the bullet and then it fires there. So now I'm going to talk a little bit about object and bandwidth, the bandwidth estimation. So as you can see in here, bandwidth estimation, I have that client outputs average is about 310 bytes, and 110 bytes per second is the input for client. So let's say that you will need all objects in the packet with all headers and IDs, like full packets. Then you will need, how many packets is there sent per second? I said 20 because I know that a packet is not sent each update, but every 4 or 5, as I was running some tests. And then you have a number of players. So I was like saying that average would be 300 bytes multiplied by, let's say, 20 packets and by 10 users, which would give us 60,000 bytes per second that needs to be sent from server for 10 clients. This of course can vary. Now this will go up with the amount of clients as objects will grow as well. Now with upload speed of 2 megabits per second from a server, that's about 262144 bytes per second. Now you can support it around, if you divide it by 60,000, that is 4.3, which is 43 clients, which is, I would say, about 40 clients, even less, depending on how much data in each packet. So I would say that with 2 megabits per second upload from DKIT college network would be 43 clients. If there is a more upload, which I'm sure that there would be if the network is not busy, you could support more clients. I would say it all depends on the testing. So now I'm going to talk a little bit about game persistence. So we have this high score that if I'm going to check on a server, as you can see, update high score and a high score. So we have a file which keeps the track of the high score, and then whenever there is a new high score of I keep it for UFO. So if there is a player, it'll keep his name and keep his score and save it into the high score. We wanted to implement also a function which you can check the high score on the client, but as we didn't have enough time, we don't have it implemented. So I would say that I covered everything that is required, and thank you for your attention, and good night or good day from me and Paddy.